and 1 mark for nomenclatures. Two marks for this front view and top view, 2 marks for this front view, 2 marks for this front view, and 1 mark is for these names itself. If you write just front view, true shape and sectional top view, you will get 1 marks, because students forget to write the name of views and also they ignore to insert the dimension. So you should take care about the insertion of the dimensions at least once in diagram, so that it could be easily redrawn by anybody. For example, this height and this diameter should be represented in first drawing, then this angle should be represented once only. Here it is not needed to represent the height or width of this triangle. Now problem number 3 of cone. A cone base diameter 150 mm and axis 200 mm long is standing on its circular base on horizontal plane. A sectional plane making an angle of 45 degree with horizontal plane and passing through the midpoint of the axis is cutting this cone. Draw its front view and sectional top view. Here cone is given and it is cut by a cutting plane which passes through midpoint of the axis, but before that it is given that a section plane makes an angle of 45 degree with horizontal plane. So again here angle with horizontal plane is given for a cutting plane, hence its front view would be cut. We will have to cut its front view and accordingly its sectional top view would be there. So this is the short data. Cone 150 by 200 means diameter is 150, length is 200, resting on base on HP, cutting plane 45 degree to horizontal plane and passing through the midpoint of the axis. So if we cut the cone like this would be the isometric view. The cone would be visible like this, and as the cutting plane passing through the midpoint, this elliptical shape would appear in the true shape as well as in top view. So for this cutting shape, this would be the top view, an elliptical shape in the top view, and this would be the front view. A cutting plane line which makes an angle of 45 degree with horizontal plane or XY line and passing through the midpoint of this axis. So first we have to draw top view of this cone, that is a circle of diameter 150 mm. Insert the dimension diameter 150 mm. Draw the center lines, horizontal center line, vertical center line. Draw projection lines like this and draw a triangle having height 200 mm. Up to this step it's clear to us how to draw these two steps. Now draw a cutting plane line which makes an angle of 45 degree with horizontal plane, means XY line, and it passes through the midpoint of this axis. So this height is 200 mm. So at a height of 100 mm, mark a point over here, and from that point draw a cutting plane line at an angle of 45 degree with this XY line like this. Now next step is to find out the points of intersection. Name the endpoints 1, 2, 3, 4. Divide this top view into equal number of parts. Name the endpoints 1, 2, 3, 4, 5, 6, 7 and 8. This is apex point O and apex point O dash in the front view. Now draw projection lines from all these imaginary generators. 1 O dash, 1 dash, O dash 2 dash, O dash 3 dash, O dash 4 dash like this. Then find out the points on cutting plane which will be on the cutting plane as well as the generators. For example, here is point number 1. Here, somewhere here. So this cutting plane cuts this generator at this point. So from that point draw a straight vertical line like this. So from this point a straight vertical line, it will cut O1 imaginary generator at this point, right? Let me revise this thing. O dash 1 dash is this generator, intersection of this O dash 1 dash and cutting plane is this point, and from this point draw a straight vertical line that will cut O1 at point number 1. So here is point number P1. With the same analogy, find out the point of intersection between this imaginary generator O2 and this cutting plane. So it would be somewhere here, and from this point draw straight vertical line like this, and that will cut O2 at this point and O8 at the same point somewhere here. Point number O4, from this point straight vertical line, it will cut O4 at this point. Similarly O5, straight vertical line from this point, it will cut O5 at this point. Similarly for O6. And what should we do about this point, this midpoint? So for that we draw a horizontal line from this point. It means that the position of this point is transferred to the true length of this generator. As we know, this O1 generator represents the true length, so this point is transferred to the true length somewhere here. From that point, draw a straight vertical line that will cut O1 at this point and draw an arc on this upper side as well as on this lower side. So 2 points are here. So we have identified all these 8 points, 1, 2, 3, 4, 5, 6, 7 and 8, and join all these points with the smooth curve like this. Smooth curve should be used to join all these points, and with internal portion should be removed or erase this portion as it's not needed, and draw section lines in this sectional view. As it's a sectional top view, draw section lines which makes an angle of 45 degree with this reference line, that is XY line, and all these lines are equidistance line. Now name the view. Now what should we do to draw true shape of the section? As this cutting plane is inclined at an angle of 45 degree, this view doesn't represent its true shape. So to draw true shape of the section, let me find out the distance of respective points from XY line and transfer these points from this cutting plane to this side. So for that, from this point draw a line perpendicular to this cutting plane line as we did in the first problem, and measure the distance of this point in the top view. Measure this distance, point number 5 to XY line and point number this to XY line. So mark it point over here, this is point number 5. Similarly draw a line perpendicular to this cutting plane line from point number 4 like this, and transfer the points from this top view, position of point number 4 or P4 and P6 from XY line. So 2 points would be here. Similarly point number P3, P2, P1, P8, P7 and P6. These are the points, and join all these points with the smooth curve. It would be a perfectly elliptical shape. So it's an ellipse. It represents the true shape of the section. Here also remove these internal lines as it's not needed, or you can lighten these lines and draw section lines or lines makes an angle of 45 degree with the reference line. And name the views. It's a sectional top view because section is there. This is the front view of this cone, and this represents the true shape of the section, which is elliptical shape. Here also you should take care about insertion of the dimension. Insert all the dimensions once only in the figure. Name respective views, say front view, true shape and sectional top view, and also write down the scale which is used to draw this drawing. If you have used the scale 1/2 or 1/4, appropriate scale should be written below this figure anywhere. And as we have not inserted the unit of the dimension, you should write a one line in the answer paper in the first page that all the dimensions are in millimeter. So it's not needed to write millimeter everywhere in this drawing. Only one line should be written that all the dimensions are in mm. So that is problem number 3. Now next problem, question number 4, and the data for fourth problem is given like this. A right circular cone of base diameter 75 mm and 80 mm height lies with one of its generator on the ground. Draw its projections. It is cut by a cutting plane parallel to horizontal plane and passing through the center of base circle. Draw front view, sectional top view and true shape of the section. Here also a cutting plane is making an angle with horizontal plane. it's parallel to HP, and hence its front view would be cut. This is the short data for this problem. Cone 75 mm diameter, 80 mm height, resting on HP on its generator, and cutting plane is parallel to horizontal plane and passes through the center of the base of circle. So this is the cone. This is the given condition. It is resting on its slant edge or its generator, and this would be its top view. If we tilt the cone in such a way that it is lying on its generator or its slant edge, this would be its top view. And this elliptical shape shows this bottom shape. As it's a circular, in top view it would appear as a elliptical shape, and this ellipse would be fully visible because this edge is towards us. And here cutting plane passes through the center of the base circle. So the center of base circle would be somewhere here, and from this point a cutting plane should be drawn like this. A horizontal line or line parallel to XY line represents the cutting plane of this cone. Now let me draw this problem to have hands-on experience and to draw its sectional top view and true shape of the section. Let me draw this problem. So up to this step it's clear to you how to draw this top view. Top view is a circle of diameter 75 mm and front view is a triangle having height 80 mm, so that dimension can be inserted. After that we have to tilt this front view like this, and after tilting take projections from each point and draw top view. This we did in previous examples as well. Now this is the cutting plane which is given, which is parallel to horizontal plane. So cutting plane should be drawn like this. From here two long days, small days, one long days, like this, one long days, and here arrow is drawn like this. It means that the material or towards this arrow side is removed. This upper material is removed and this bottom material is retained with us, so that we can darken the remaining portion of the cone like this. In examination you have to darken this portion with the pencil only and do lighten this upper portion. There should be difference between this upper triangle and this lower portion. That's it. Now to draw its top view, let me name the endpoints over the periphery of this cone. See, here is point number 1, 2, point number 3, 4, point number 5, 6, 7 and 8. As it's a top view, dash mark should not be there. This is apex point O. Similarly, apex point O dash would be here. Here is point number 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash. All the points are here, and transfer all these points to here. Here is point number 1 dash, 2 dash, 3 dash, 4 dash, 6 dash, up to 6 dash, 7 dash and 8 dash. 8 points would be there, and here is apex point O dash. So first draw its top view. Vertical line from point O dash, horizontal line from point O. Here is point O. Similarly, vertical line from point 1. This is the line. This is point number 1 dash. So vertical line from point 1 and horizontal line from point 1. So 1 point would be here. Similarly, point number 2, horizontal line from point 2, vertical line from point 2 dash. Point number 2 would be here. Point number 3, with the same analogy, point number 4, 5, 6, 7 and 8. 8 points are drawn over here, and join all these points with the smooth curve, which we did in the previous example also. So I am skipping that step. We are not going to discuss in detail about that step, as it's a just revision of the first problem, because all problems are of similar kind, just the position of cutting plane is different in various cases. Now join the imaginary lines over the periphery of this cone, means apex point O with 1, O with 2, O with 3, 4, 5 and so on. Now our exercise starts. Find out the position of points of intersection between the cutting plane and generators. Let me start from here. Here is point number, first point on 5 O dash 5 dash. Here is point number 1. First point would be here. We name it as P5. The intersection of this generator O dash 5 dash and this cutting plane is this point. So from that point, draw a straight vertical line, and this straight vertical line will cut this O5 at this point. So mark that point somewhere here. This is point number P5. As it's a front view, dash would be there, P5 would be here. Similarly, another point would be here, intersection of this cutting plane and O dash 4 dash and O dash 6 dash. So here 2 points would be there, point number P4 dash and point number P6 dash. And from this point, draw a straight vertical line like this, and that will cut the generator O6. O6 is the generator over here, and O4 is the generator over here. Here is point number P4, and here is point number P6. So we have identified 3 points, P4, P5 and P6. Similarly, point number P7 would be here. P7 and P8, both the points would be here. So from this point, draw straight vertical line like this, and that will cut 7 and 8 over here. So join them with the straight line as it's a base like this, and all these points should be joined with this straight line with a smooth curve. So this smooth curve would be there like this. As it's a cone is cut, so it is having a curvature shape. As it's a the cutting plane is parallel to this, parallel to one of the generator, this would be a regular parabolic shape. A regular parabola would be there, and after that this internal portion should be erased as it's not the part of the object. This curvature shape should be erased like this, and the section lines should be drawn in this parabolic shape. So these section lines again should be drawn in such a way that it makes an angle of 45 degree with XY line, that is our reference.